The name of the file is heart_disease.
Ma'am, we have a small request.
Yes.
Please increase the text size of the code. Please zoom it up a bit. Okay.
Is this okay?
Yes. I hope it is okay with everyone.
This train test split, this you can take from the previous slide, previous program. Line number 18 and 19. This is similar to the previous program. Then you can move to line number 21 to 23. We learnt from here that feature scaling. Okay, so I hope this is done. Have we completed till this point? So steps were very simple. We have uploaded the data, imported the data, before that library importing, and then we have segregated, means splitting the data set into training set and test set. Then we started with this scaling part, and we have scaled our features and labels, right? Features, all features that is in training also, and that is in testing also, right? After that, we are calling the classifier from that. We are taking this constructor classifier from the class logistic regression because we want to fit into that model, and then comes prediction. Now, if I run this program, you may check what is variable explorer that is saying, right? So let us see what variable explorer says. Variable explorer, in this case, if I check my features train, right? You can observe here few values are negative and few values are positive. This is what we discussed in feature scaling. We said mean of every column would be 0 and standard deviation would be 1, and it will happen, right? So this is how feature training works. Now our 3-digit data has been scaled to these particular digits, right? Similarly, we have features test that also you can observe, right? So all data is scaled, that is features data, okay? After that, once we have predicted our labels from this features test, now I want to check what are label predicted and what are the labels that is from test data, right? What actually is and what I have predicted from testing, right? That I want to check, right? So let us see my frame over here, right? So if I see my frame, it says these are the values that has been predicted, right? What is the value? 2, 1, 2, 2. Means predicted value is 2 and the value the actual value is 1. Predicted value is 2, the actual value is also 2. So here is the concept that is next that we are required to build with, right? So what is the concept? Suppose we have, this is called confusion matrix. Suppose we have, let me add one more slide into this. Okay. Yes. The value, see what we did, we had features, we had labels, right? Out of features, we had training data and we had test data. Labels also, we had training data, we had test data. Now, training data was used for that fitting, and testing data is used to check whether the model responded good or not, whether the model was responding that is closer to my final output or not. So what we did, we have taken features test and we have found labels test are given to us, right? Labels test data is given to us. What we are doing from this features test, we are finding out or we are predicting the values of labels, right? And these predicted values, if they are equal to or closer to actual predicted values, right? Actual values, right? One is that is given to me jahan se I have taken test data. Test labels are with me. So that test label wala, that is called actual value, right? Because that is given to me, right? Second thing is predicted value, because I have taken features, test features, and predicted some values for that test features, right? So I want to compare these two values, actual value and predicted value, kiski? Labels. Now, when I am predicting these values, it may happen that actual value said that heart disease is there, the person is heart patient, but predicted value said no, it is not. It may also happen actual value was the person is not, but predicted value was yes. It may happen actual value was also yes, predicted was also yes, and it may happen actual and predicted both were no, right? So these 4 set of values we may get, means there may be values which are matching with the actual values, the predicted values are same, and there may be some values which are not same, right? This particular matrix will actually tell me how many values are correctly predicted, means whatever was actual value, that is predicted correctly. So this matrix is called as confusion matrix. What we call it as confusion matrix, right? So this is a performance metric for me to check whether my model performed well or not. So how to do it? What I'll do, I have actual values on one side, predicted values on second side. Actual value can be 1 or 2. Predicted value can also be 1 or 2. Let us say from our data set, we have total 53 values which said actual was also not hurt patient and predicted also not hurt patient, right? Similarly, we have some 16 values which said the person was hurt patient. It was actually also and it was predicted also, right? This is say 9 values when the software when actually the person was not heart patient, but it was said it is heart patient, predicted it is heart patient. And there are total 10 values which said person was heart patient actually, but prediction was the person is not heart patient. So what we must understand here, we must understand that these two values are of very importance, right? So important values are 53 and 16 because these are actual and predicted matched value. यहाँ पे actual value is also same, predicted value is also same, right? So what I'm going to find out now I would find out my confusion matrix first, and second thing I would find the score of this model. How to find out score of this model? I would find out kitni correct values hai, means correctly actual and predicted both are same, right? After that I would find out total how many values, right? Find out it would be 0 point something. So I can say this is the score of my model, right? In case of classification, it is very difficult for us to decide whether we should go for logistic regression, whether we should go for SVM, whether we should go for something like nearest neighbors and some other model, or naive based we can say, because that is actually used for natural language processing. But other models, it is really difficult. So what we do, you must have heard from the people who are from machine learning background that I tried this model, I tried this model, I tried this model, and the score of this model was best. So that's why I am basing my research or my project on this model, right? It may be, I'm not saying KNN is always best. It may be SVM, it may be LR, right? So what we are going to do now, the next step would be after prediction, after doing this, what we did here, we predicted. After that, we are comparing the predicted and actual values. To compare it, we have put it in a data frame. We saw that there were some values 2, 1, 1, 2, 2, 2, and so on for all the rows, right? Printed that data frame to just check what are the values. And after that, we are creating this confusion matrix. Confusion matrix ke one side pe you have actual values, one side you have predicted values, right? When actual is 0, predicted is 0, this is called as true negative. Means actual says this is not the fact, like this is, there is no heart disease. Predicted also said this is, there is no heart disease, right? Then it would be called as true negative, means true false, right? Both are negative, means correct. True negative, true means correct. Here it is true positive, both are positive, and true means both are actually matching, right? Similarly, we have false negative, false positive. False negative means actually it says false, but actually it says true, but predicted is false. Here, actually it says 0, but predicted is 1. So what we are requiring true negative and true positive, right? How to do it? To do this, again, we will use sklearn. From that, we have metrics. Metrics means all performance metrics are there, right? And from this, we are concerned about confusion matrix, right? Now, confusion matrix, again, we have a constructor for this. In this constructor, we are passing test labels and predicted labels, right? Whatever values we were given and whatever we predicted from the test data. We found that confusion matrix. That confusion matrix is in CM and we printed it, right? Now, confusion matrix for the data given to you is this. It says 53, 8, 16, 16. 53, 8, 16, 16. What does it mean? It means that these two values are important for us and we can calculate the score on the basis of what CM00. CM00 means 53. CM11. CM11 means this diagonal. Again, both true positive, true negative. And the summation of all values. 53 plus 16 plus 8 plus 16. And finally, the score of this model is 74%, or you can say 0.7419 and so on. Is this clear? Why we are generating this confusion matrix and how we can calculate the score of this model, right? So maybe you can continue with the same. The last part that we were left with for this classification problem, logistic regression, these 4-5 lines. Sonia ma'am, in the meanwhile, if someone has query, other people are doing, so we can take up 1 or 2 queries right now. Please let me know if it is done, then we can move forward.
Hello, ma'am.
Yes, yes, ma'am.
Ma'am, line number 19. A request is there. Please scroll the window to the right side for line number 19. Thank you, ma'am.
Okay, for the time being, I'm just putting it in next line so that you can see it properly.
Okay.
Please don't put it in next line because it is a syntax error. We are required to put it in same line. This is done. I hope it is done. Please raise your hands if it is done and we can move forward.
Yes, ma'am.
Okay, thank you. Others? So could we get it? The score and confusion matrix. I hope this should be same for all because we have given random state equal to 0, right? This is something that we are going to execute and find out the values, right? Now coming to the PPTs once again, taking another example. Now this example says, this is again healthcare data, which says there is a woman with age 22. This is her first delivery, right? at what time it was there, and what is blood pressure, whether she had heart problem or not. So with all these features, it is required to predict whether the delivery is going to be cesarean or not, right? Whether it would be C-section or not, right? So for this data, definitely, because 0 and 1, answer is from 0 and 1, we are required to have that classification, right? Now, which algorithm? Again, we can have logistic regression also. Other algorithm we are taking now, we are considering now is K nearest neighbor, right? Now, thing will start from pre-processing as we did till this particular time. We'll have data set, we'll have labels, we'll have features, we will import train test split, we will split the data, random state 0, standard scaling, not required much, but if you do, because there is 1-digit or 2-digit data, not required, but if you do, there would not be anything going from your side, so we can do it also, right? So this all is about pre-processing part, right? So feature test, feature train, both are being scaled here. Now coming to K nearest neighbor, actually what happens? Now let us see the concept of K nearest neighbor. Let me put my slide, blank slide here, and understand it. Okay, so K nearest neighbor concepts that starts with features on x-axis and y-axis, and then plotting the points according to the features, right? Let us take an example that this is the latitude and this is the longitude. In this particular city, for a particular area, we are finding whether the person is corona positive or negative, right? Now, suppose a person comes here in this locality with this latitude and longitude, a person is entering, and we are required to check with what is the probability of being this person as positive or negative in few hours, right? Because it is a communicable disease, right? We can check what is the nearest, I mean, what is the probability based on the nearest neighbors, right? So nearest neighbors ke base pe we are required to find out whether the person would be corona positive or negative, right? So what we are going to do here, we are going to take few neighbors which are very close to it, right? How many neighbors? If I am taking, in general, we say K nearest neighbors. That's why it is KNN, right? In general, we can take K is equal to 3, K is equal to 5, K is equal to 7. What does it mean? If I take K is equal to 3, 3 means 3 nearest neighbor. 1, 2, 3. Now, how to find out nearest? To find out whether this is nearest or not so nearest means I am required to find out the distance between neighbors and this entering city, right? So first thing I require is distance. Second thing I require ki what should be the value of K. These are main points in K nearest neighbor algorithm, right? K nearest neighbor model. Distance, to find out distance, we have two methods. One is called Euclidean method and second is called Manhattan method, right? We'll see both of them. And to find out K, we have to keep in mind two things. One is K should always be odd number. Why it should be odd number? Because if I'm taking even number, so the probability is that negative and positive numbers are equal and we will not be able to find out which one, what is on majority side, and we will not be able to classify it. We will not be able to assign a class to it, whether the person would be positive or negative, right? So K has to be an odd number. By default, we take the value of K as 5, right? If we take lesser than 5, then it may not give us correct results. If we take more than 5, then it would be very cumbersome, right? So k is equal to 5 is generally that is taken. Okay. So next point comes how to calculate the distance, right? Again, repeating what I said, we are learning another classification algorithm, that is k nearest neighbor. Data pre-processing steps would remain same. I want to classify a newly coming point to one of the categories, and I have taken one example of COVID positive and COVID negative. So there are two categories. One is COVID positive, second is COVID negative. So one of the person who is entering into a location of this, I know what is latitude, what is longitude. I want to calculate, I want to check in which class it should lie, whether it should be COVID positive, whether it would be COVID negative, right? In which class it would go, right? How to predict it? To predict it, I require the nearest neighbors. I'll check what is the majority. If majority of the people are COVID negative, I would say this person is going to be COVID negative, right? If majority of the people are COVID positive, then definitely you have more chances of having that COVID positive symptoms, right? Clear? So we are moving to the how to find out the distance in k nearest neighbor. K ki value 5, we have fixed it, right? So before k nearest neighbor, this is the new data point that has occurred. We are required to find whether category A or category B, right? Because nearest neighbor said ki they are, this is more closer to the green points, so we have make it green, right? So category A. Clear? How to find out this distance? Next point is that. Let us see how to find out distance. Just a minute, let me erase this. Okay. So to calculate the distance, I said there are two methods. One is Euclidean distance that we have learned in our previous years. And second is called as Manhattan distance, right? Now, what happens in case of Euclidean distance? We will take a point P, P1. This is point P2 and find the distance. How to find the distance? We know the distance formula, that is P1, P2. Distance would be found. This is if it is x1 comma y1. This is x2 comma y2. The distance we will find out as x2 minus x1 ka whole square plus y2 minus y1 whole square. This would be called as Euclidean distance, and we have learned it, right? KNN generally use it, but there is another method also, right? Now, what is P1 and what is P2? One of them would be the newly entering point, right? New set of features, and second of them would be old, right? So we are finding out what is the distance. Next is Manhattan. Now, what is Manhattan distance? In this case, we have, when we have 2 points P1 and P2, first of all, we will calculate the horizontal distance of P1 from P1 to this point. Then we will calculate vertical distance from this point. So we went horizontal and then vertical, right? So what I can say, if this is the coordinate of P1, this is the coordinate of P2, then Manhattan distance would be equal to absolute of x2 minus x1. I'm talking about distance, right? Plus absolute of y2 minus y1. I can write it. Absolute of x2 minus x1 from here to here, horizontal. Absolute of y2 minus y1, it is vertical distance. So this is called as Manhattan distance. Now Euclidean distance is better, Manhattan is better. It actually doesn't make any difference to us because everything is to be done by model. We will just check it, which one is giving us better score, right? So Manhattan distance, one more thing, Manhattan is actually a road in an area in New York where every road is crossing each other at 90 degree. That's why it is called as Manhattan distance, right? So just came into my mind and I thought, let me tell you, right? So we are required this. Again, we would go for similar steps. One is pre-processing. After that, we would have that fitting. Then we will have prediction. Then we will have confusion matrix, and then we will have score. Right, while pre-processing all those steps, feature scaling if required, if we uploading of data, importing of data set, features, extraction, label extraction, then train, test, split, all those things. While fitting, we would be taking help of sklearn library. Now, out of sklearn, when I am creating a constructor called classifier, I would be requiring two parameters. What are those parameters? I would be requiring the value of k, and I would be requiring the value of p also. Now, p key value can be either 1 or 2 depending upon whether it is Euclidean distance, or p means distance, how I am calculating it, whether it is Euclidean or Manhattan. K key value, you can put anything 3, 5, 7, but it should be odd, right? So what is the algorithm? It says we are required to select the number k of the neighbors. We are required to calculate the Euclidean distance of k number of neighbors, right? Take k nearest neighbors. After calculation of distance, we are required to have the closest k neighbors, right? Among these k neighbors, we are required to count the number of data points in each category. Suppose I had 5 neighbors. Now I am required to find out from this newly coming point which category numbers are more closer to this. If negative numbers are more closer, then this means we would categorize it as negative, otherwise positive, right? This is how k nearest neighbor is working, right? For example, here you could see after finding out distance, we could find out there are 2 neighbors from category B. After calculating distance, 2 nearest neighbor from category B and 3 nearest neighbor from category A. So what will happen? This point has to go in category A, right? So we are required to implement it, and we can see all other points same. When we are fitting this, we are importing k neighbors classifier. So P is equal to 1 means Manhattan distance, and P is equal to 2 means Euclidean distance. So when I would be constructing, when I would have a constructor, so I would pass neighbors and then the the method of calculating distance, right? Then I will fit this algorithm, and then I will predict it. And then after that, we know that we will compare labels predicted, labels tested. My frame would be there, and then confusion matrix, and then the score. So this is the story of k nearest neighbor. Any doubt? Yes, do we have any doubt? Should I share another data set? I guess post lunch, we have become a bit slow. Is this? I mean, I can feel these vibes. I don't know whether it is correct or not. I hope you all are doing wonderfully, but please let me know. Should we go ahead with the program? I should share the screen and data next. Okay, raise your hands if it is clear to you, K nearest neighbor. Okay, thank you. Thank you, Sabita ma'am. Thank you so much, Bhavna ma'am. Okay, so sharing the data with you, and that can be taken cesarean, right? Sonia ma'am, please share the next file. So after taking next file, I've told Sonia ma'am to share that file. See, the things would remain same. The changes would be
Hello.
I have shared.
Okay, okay. I'm sharing it out.
So what we are required to do, again import library. Just change the
Ma'am,
file
I have
name. You can
shared
take.
the other file.
Okay, thank you so much.
Hello, Pooja ma'am.
Yes, yes, I can hear you, Sonia ma'am. Thank you
Hello,
so much. Hello, am I audible?
hello.
Hello,
Am I audible, ma'am?
Sonia ma'am, I can hear you. You can't hear me?
Yes, ma'am, you
Hello.
both are audible.
Okay, okay. I have shared the second file. Audible, ma'am, now.
Okay. So you are just required to change the name of the file. Just check it out. How many labels, how many features, right? Here you would be having 5 features. Take those features. After that, test train split would remain same. So changes required are with the file name, maybe for the features. Also we have done in the previous program, so no need to change it. And then we would be requiring the changes in line number 32, line number 33, right? So these lines require changes. After these 5, 6 changes, you are done with this k nearest name. This is done. Could you get the confusion matrix?
Yes, ma'am, it's done. From my side, it's done.
Okay. What about others?
Please, can we have a feedback? Is it done? Can you raise your hands? Anything? A small feedback from you?
Should I wait for more time? I can understand. Post lunch.
I hope it's done. Otherwise, I would have got a query on the number.
Okay. Silence means let us assume that it is done.
Yes, silence means we'll assume it's been done.
So moving on to the next part now. That is support vector machine. In case you have any query, we can talk, because another two things that we would be having, that we would understand conceptually more, right? We'll do a program in case you want. Otherwise, concept is more important here. What is support vector machine? See, SVM, again, a classification algorithm. Now, classification always said there should be two categories, right? But in this particular case, see, if such kind of thing is available to us, such kind of data is there where you can clearly define a boundary in between, right? It is very, it is a correct method to find out which category a newcomer would go. Yeah, a new data that is to be predicted that would go, right? We can assign the category very easily, right? But if we have something like this, right? If we have this thing, this would be called as linearly separable. Means you can put a linear equation, or you can put a line over here and you can just identify which category in first case. In second case, this is not at all a linearly separable, right? This line, in case of classification, this is called as decision boundary, right? Decision boundary means this is the boundary that will let me know whether a new point should go to class A or class B, right? But in this case, we cannot draw a decision boundary, right? So when we have such kind of data where it is very difficult for us to find out linear separation, then we would be using what we call as support vector machine, right? SVM. Now, in case of SVM, actually what happens, let me put another slide to explain the concept. Okay. So in case of SVM, what we are going to have, let us assume this is the plane. Here we have all the points which are from category A, right? And I have another set of points which are of category B, right? Now what I'm going to do, just visualize it. I am going to pick this plane from the center. I'm going to pick this plane from the center, and you understand when I am putting it, this would be something like this, wherein I would have all the red points on the boundary, all around the boundary, and all the blue points which are from another category that would be towards the center, if I'm picking it up from the center, right? Is this clear? Now, when I'm picking it from the center and I have identified this boundary, now I can say that I can definitely do that segregation. Now, this is called decision boundary, or in case of non-linearly separable points, this is called as hyperplane, right? So in case of SVM, we want hyperplane or decision boundary of the data which is not linearly separable, just like this, right? If you cannot identify the category on the basis of features, you cannot identify in which category it would go. So you would be talking about SVM. And here, this is the thing that would work. This is there in this video also. You can just check it out. It says that how hyperplane would work. This is a video you can find on YouTube also. See, there are blue, red dots, right? Now, this is the plane which is linearly not separable. Center is taken, it is picked up. Now you can say there is a plane called hyperplane which will come and cut it. It is able to find out the boundary, right? Sorry. So it is able to find out the boundary. Now the projection of this plane gives me that hyperplane, gives me the decision boundary, right? This is how we can find out hyperplane. Okay. Now to find out hyperplane, we have different functions, right? And these functions are called as kernel function. You may have polynomial kernel, you may have Gaussian kernel, you may have Gaussian radial basic function, Laplace RBF kernel, and so on. You can check, this is the website from where you can get many different kernel functions and how they work, right? So this is data flare and SVM kernel functions. We have different kernel functions and you can see how they work, right? Okay. Now this SVM, again, it will have all those steps of data processing and everything. If I go to my spider, you can see here I have data for matchmaking, right? In this matchmaking data set, let me check what is data set, matchmaking file. A female with age 24, male with age 30, whether they would marry or not, whether there is a match or not. So this is the data given to us, right? In this particular data, again, there is a number of, large number of, in fact, large number of rows for us, around 500. So out of this, again, we will do all those things like importing of libraries, uploading of data, extracting features, extracting labels. Now see here, the features and labels both are 1, right? After that, we would be splitting the data set. Then we would import from sklearn what we are going to import, that is SVC, right? SVC support vector for classification. We are using kernel function. Kernel function means a function which is required to get the decision boundary, right? We would be passing it as a parameter. So we are using it as poly. After that, again, same point, fitting of the model, again, same prediction of the model, checking the test data and predicted data. After that, confusion matrix, and then the score, right? So this is all about SVM, right? Support vector machine. Should I share the file with you? Matchmaking.
Yes, ma'am.
Just sharing this file. Sonia ma'am, I hope you received.
Should I share it, ma'am?
Yes, please share it with all.
Okay.
Again, for this, changes would be in file name, features and labels. And then after that, changes would be in this part.
Shared, ma'am.
Please continue with this. Please continue with this. And then at 3:30, maybe we can start with another algorithm. I'll take another algorithm for 10 minutes and then 20 minutes for Q&A, right? So whatever doubts you have, let us clarify. So I'll just complete one more algorithm, that is naive Bayes, and then we can continue with the question and answer session.
Okay. Ma'am, please scroll down the window.
Okay, I hope it is done. So, any queries till now? Could we get how to implement these models? Supervised machine learning. Yes. Was this OHT, overhead transmission?
Overhead transmission, ma'am.
Which part?
Please,
Can you
can we have a
specify?
feedback?
Please share the feedback.
Please at least share the feedback on WhatsApp so that I can post it to the speaker.
Be really great help for me
Yes,
to get the
obviously.
feedback. I would be able to modify wherever I can. I would be able to change it. Please let me know. Sonia ma'am, in the meanwhile, you get the feedback. Let me come to the last part of the session.
Yes,
So,
sure, ma'am.
starting with naive-Bayes algorithm.
Yes, sure, ma'am.
Now we are not going to implement it. We will just revise the concept
We
and we
have
will.
got the feedback, ma'am. I'll share with you. Just a minute.
So, naive-Bayes algorithm is the last one and last one for today. It's not the end of machine learning or supervised machine learning. It is actually based on three things. One is Bayes theorem, and second is naive principle, and third is Laplace theorem. Actually, why we require it? We require it whenever we are dealing with natural language processing kind of things. For example, I want to check whether the posts on Twitter they are good or not, whether they are more relevant to politics or they are more relevant to sports, or I want to check uh, that whether the reviews of a particular company whether they are positive or negative. Right? So if I want to classify as per these,
Excuse me, ma'am. I've shared some
yes,
feedbacks with you on your WhatsApp.
sure, I'll share the PPTs and the code as well. I'll put it in my drive folder and will share the link with all of you. Thank you so much. These are very positive remarks. I mean, good feedback for me. Thank you so much. And we'll share other details also. So coming back to the naive Bayes, here we would be having NLP based problems. For example, I have given you two examples. One is Twitter data, one is reviews of a company like this, right? Let us see one example, how it works. This is the data given to me. This is a text, a great game. And I want to label it whether it is from sports category or not. Because there are just two categories, definitely it is a classification problem. And because it is involving natural language, so I can say that I must apply naive Bayes, right? This algorithm. Uh, Second is the election was over. Definitely it is not sports. Very clean match. It is sports category, clean but unforgettable game, sports category. It was close election, not sports, right? So next is what is the data to be predicted? The data is a very close game. Now we are required to predict whether it is from sports category or not sports, right? How to classify it? This is naive Bayes. This is the fundamental of naive Bayes. So I said it works on three principles. One is Bayes theorem. Now let us see how Bayes theorem works for it, right? Bayes theorem will help me to find out the probability. Now what I'm going to do, because I'm talking about Bayes theorem, I'm talking about probability. So I'm going to check whether what is the probability of being it from sports, whether what is the probability of getting it in the category of not sports, right? What was the sentence? This is my aim. A very close game. whether it is from sports category, whether it is from not sports category. Now you can well imagine, well visualize that this is kind of Bayes theorem, right? What kind of Bayes theorem? We know that Bayes theorem says probability of an event, when some event has occurred, this is the probability, right? Now, if I want to find out the probability of first case as well as second case, now I want to find out probability of both. How to find out the probability? Bayes theorem, right? Bayes theorem will work. I started finding out the probability, and it says that P of being it from sports, given the sentence a very close game, that is like this. It will convert, Bayes theorem says, P A by B is equal to P B by A multiplied by P probability of A divided by probability of B. So P A by B is equal to B by A multiplied by probability of sports and divided by a very close game, right? Similarly, if I want to find out probability of not sports also, you can well imagine that in both the case, in this denominator would be probability of a very close game. Probability of a very close game. Numerator will change, but denominator will remain same. Now, because denominator is same in both the cases, so what we can do, we can discard the denominator and we'll compare the models on the basis of numerator only. Any doubt till now? What I said, we are given some text. In this text, I want to label it. To label it, I need to check whether it is from sports, not sports. A test data is given to me, a very close game, and I need to label it, right? For this, I need to find out probability of both the categories, whether it is from sports or not sports. To find out the probability, I applied Bayes theorem. In Bayes theorem, when I was applying on this, it gave me denominator as probability of what? A very close game, right? Similarly, for this also, denominator would be probability of a very close game. Because both are having same denominator, so what I'm going to do, I'll discard this denominator, right? I'll discard this divisor because this is same for both. And I'll compare just the part that is in numerator, and that is probability of a very close game by sports multiplied by sports with this. So these two comparisons I'm required to do. Right. So Bayes theorem has given me this thing. Now second thing comes, yahan tak Bayes theorem ka kaam, it's done. Now I am required to find out next thing that is based on Nave principle. Now Nave principle says that whenever I want to find out such kind of probability, this particular factor, to find out the probability of this, let us find out probability of A by sports, multiply it with probability of very by sports, multiply it with probability of close by sports, multiply it with probability of game by sports. Similarly, multiply A by not sports, multiply very by not sports, multiply close by not sports, multiply game by not sports, right? If we want to find out probability of a very close game, so we are required to find out probability of A by sports, very by sports, and multiply all of them, right? Similarly, not a very close game by not sports also, denominator will become not sports everywhere. And we know that with this, we were having one more factor. एक probability हमको ये निकालनी थी, एक probability हमको ये निकालनी थी, right? This we have found from Nave principle. And what about this probability of sports? Probability of sports, we can say it is 3 by 5. Why 3 by 5? Reason being, here are total 5 rows. Out of these, 3 are from sports, so 3 by 5, and probability of not sports is 2 by 5, right? So this is how we have found probability. जो multiplication factor था, that we have found. Now comes, if I want to find out probability of A by sports, what I'm required to see? I need to check how many times A occurs in sports wali category, right? There may be the case, just see, there may be the case that one word is not there. For example, close is not in any of the sports wali statement, right? So this will become 0 and the answer will finally become 0. This is what we do not want, right? I'm repeating. I found probability from Bayes theorem. In that, we required two things. One thing was this probability of sports, and this thing was there. This thing we are going to find with the help of Naive principle. This thing we know that because there were total 3 from sports category out of 5. So 3 by 5. This is 2 by 5. Now to find out this by Naive principle, what we did, we segregated each probability, and finally I am just letting you know that it may happen out of these sports statement, there may be some word which is not belonging to this sports statement. So if it comes out to be 0, then whatever value others have, it will become 0. Now for this purpose, we would go to third concept, and the third concept is Laplace smoothing. Laplace smoothing. So what I did, I calculated the value of all unique words are taken, and I have calculated the probability of A, that was 2 by 11. In this, I am adding what I am adding 1 to the numerator everywhere. You can see I am adding 1 to the numerator. Why I am adding 1? Because if it is 0 by 9 or 0 by 11, answer would be 0, and that is not actually what we want. सब कुछ 0 हो जाए तो we will not be able to evaluate, right? So I am adding 1 to the numerator, 14 to the denominator, because I have total 14 words, 14 unique words in the given text that is given to us, right? Is this clear? So this is called as Laplace smoothing. Once I found this, I multiplied everything, and after multiplication, this is the result. After multiplication, this is the result. Now, which one is better? This one is better, right? Which probability is less? This is less. So I can say that which word is belonging from which category. This is how we compare between, we find the probabilities, and this is how we go for this concept of Naive-Bayes classification, right? It is based on 3 concepts: Bayes theorem, Naive principle, Laplace smoothing, and then we go ahead about it, right? This is something, a totally new concept, and that requires a lot of time to understand features, labels, and all, but I have shared the concept, and with this quote that you have to learn the rules of the games. Today, I tried to explain few rules of the game, and now you are required to play better than everyone else, right? So I hope you would be working on it, all machine learning algorithms. You will have some research papers, you will have some projects on the basis of that. And this knowledge will really help you to the extent that you were expecting. Obviously, in a day, we can't complete everything, but definitely we can try to show you the rules, right? About myself, as ma'am has already shared with you, I'm Dr. Pooja Sapra. I can share my email ID is written over here. And just today, I completed 20 years in my academics, and specialization is blockchain technology, AI, and ML. You may connect with me through this email ID in case you want. And that's all from my side. Now we can move to the question and answer round if you have.
Congratulations, ma'am, for completing 20 years.
Thank you so much. Thank you so much.
Any queries? Please raise your hand. I'll provide you with the access of mic.
No queries.
I didn't get any hands risen as yet. I hope it was very clear to everyone, ma'am. The session was very interactive.
Interaction I wanted more, but there was no access. But still, it
Yes.
was I could complete whatever I wanted, and I hope everybody could execute the code.
Yes,
And
yes. That is why I had the feedback on my WhatsApp group to scroll it
Yes.
left, to scroll it right. That means they were doing parallelly.
Right, right, right.
And yes, we were able to understand it.
So, should we close it?
I hope everyone understood it very nicely. No doubts to anyone. Still any doubts? Ma'am would share the PPTs and the code with you. You
Yes,
can all
that
execute
link.
it once.
Sonia ma'am, I'll share the
Yeah,
link with you, Google Drive
yeah.
link, right?
Okay, ma'am. Okay, okay. On behalf of BCIIT, the Narsidas Chandiwala Institute of Information Technology, I thank you for your valuable knowledge that you have provided to us today. We are very grateful, ma'am, that you spared your time for us. Thank you so much. Being my mentor, yes, you have already done so much in your research, and yes, today we have seen it was a very informative session, ma'am. Very informative. Thank you so much for the session, ma'am.
Thank you so much. Thank you so much for giving me opportunity. Thank you for host institution, Sonia ma'am, and all the coordinators who are involved. Please take such initiatives. Keep on taking it, and all the best for all future
Thank you.
endeavors to everyone, all participants. Thank you so much.
Thank you, ma'am. Thank you. Thank you for the day. Thank you. Thank you, everyone, for the day. We end up the session today. We'll join up with another enthusiastic session tomorrow at 11 a.m. Thank you for the day, everyone.